Hello friends, today we will study about the method of joints of unit number 2 mechanics. So we have studied types of frames and trusses, triangular shapes. Now we will study the joints, which are the pin joints. So how we can classify or how we can analyze that joints. So each joint of the truss is analyzed separately under the system of external forces. Means two types. One is the external force and one is the internal stress. So under the system of external forces, including stresses in the member. So joints are analyzed using the condition of equilibrium, that is f of x is equal to f 0 summation, and summation of f of y is equal to 0. So we will see the figure, that is a b c having load, point load w, and Ra and Rb are the forces from the bottom. So how we can analyze this? We can see this figure. These are all separated analysis. Mean the between the point A and point C there is a force PAC. Between point A and point B there is a force PAB. It's only for the notations. And for from point to point C to point B it is PBC. Remainings are already there, W, Ra and Rb. So let's see the conditions. If any joint having the only three forces, then we have to use Lami's theorem, which we have studied in unit number 1. If only three members meet at a point and two members are collinear, means one of two members are collinear and one is whatever it may be, and no external force is applied. If the no external force is applied at particular point, then the force in the third member will be 0. Means excepting that two members in collinear, the third member force is will be 0. And again one, if only two members meeting at a point and no external force, means external force plays important role. So if no external force is applied and only two members are meeting at a particular point at pin joint, so both members carries 0 force, or the forces in the both member must be 0. Let's explain it with the diagram. Here we can see this is diagram having the joints A, C, D, E, B, and upper joints are F, G, H, I, J. So here we can see that point number A, three joints F, G, and C. Point number C also three joint, E also three joint, B also three joint. Same likewise G, H, I are three joints. Members are joining. Remaining point F, point D, and point J, there is only two members are joining at this particular pin joint. So the forces AF, FG, that connecting the point F, same point for the J, connecting point J is IJ and JB, and for point D, HD, these forces are 0 or will be 0. Here we can see that in above figure, forces in the members AF, FG, HD, IJ, and JB are 0. Moving some of the assumptions for the pin jointed structure, I mean while solving the numericals or while analyzing this pin jointed structure, there are some assumptions, that is all members are pin jointed, no other joint is applied. Frame is a perfect frame, that is M is equal to 2j minus 3. The frame is loaded only at a joints by a point load, means only point load is applied, not other loads. Weight of the member should be neglected unless it is stated, means if the weight not to be considered, then it is not to be considered, means it should be neglected if not stated. So the centroidal axis of the various member forming into the joint should be in trace at a common point. The centroidal axis may be more than, so it should interest at a common point. So the representation of structure will be there. So there are two types of basically structure representation, is tensile forces and the compressive forces. So if the member truss carries the tensile force, then it is called as a tensile member or tie member. The names are there, and it is represented by two arrows pointing away from the joint. Means if like we are stretching somewhat, that is a tensile force. So this is a diagram of the tensile or tension or tie stresses trusses. Second one is exactly opposite of this. If the member or truss carries the compressive force, then it is called as a compressive member or strut, and it is represented by the two arrows pointing towards the joint. Means compressive. If we applying the pressure from the outer side, that is a compression. So the method for analyzing is a graphical method and analytical method. You will see the analytical method, not graphical, in this mechanics. So method of joints will be there, the same as we analyze the joints, that is summation of f of x is equal to 0 and summation of f of y is equal to 0. This is one of the method. And second method is method of section, means we are taking the sections of particular frames and there. So only one thing added in this method of moments is equal to 0, means summation of moments is equal to 0. So these are the two methods for solving the numericals. And next one is your cable. We also require frames and trusses. There is also the cable. Cable is a one dimensional structure which carry only axial tensile force. This is the most important, that cable is only having one dimensional and it carries only the axial tensile force. It is used in transmission lines, suspension bridges, aerial transways, etc. Means it is a circular shape, maybe most of time it is used as a circular. So the assumption also to analyze the cable uh, forces, we know that it only carries the axial tensile force. So assumption will be there, the cable is flexible, weight of the cable is negligible, and it carries an axial tensile force only if the forces are not defined. So you have to assume directly that it carries the tensile force. So these are the assumption and theoretical part of your analysis of stresses and the frame and method of joints. Thank you.